you all just finished a U-Try where you got to do an application of a maximum or a minimum. So let's see how this one went. So the problem says, a daycare wants to fence in a rectangular area for a new playground. The daycare building will be one side of the rectangle. All right, so we've got a daycare building and we're going to make a rectangular playground. Okay. They have 80 feet of fencing. What is the maximum area they can fence? And what will be the dimensions of the rectangle? So here's my daycare building. They're doing this rectangle where the daycare building is one side. So my rectangle over here has two lengths and a width. If you made your daycare building like the top or the bottom, you'd have two widths and a length. You could certainly draw it that way. I can do that real quick for you. If you make it like, let's say your daycare building is here, you could also draw it this way where you have two widths and a length like that. Okay? Either one is just fine. Alrighty, let's see. They have 80 feet of fencing. So what I'm going to do with mine, I'm just going to keep going with mine, is say that those three sides added together would equal the 80 feet. We're trying to maximize the area, so they're going to use all their fencing. So if I add those three sides together, I'm going to have two lengths plus a width equal to 80 feet. We're trying to maximize area. It's a rectangle, so the area of a rectangle is length times width. Okay? Let's see, from here, you'll notice my area formula has two different variables in it. That's not very helpful. So I'm going to use this first equation to solve for my width because that's probably the easiest. For me, I'll subtract 2L from both sides and get my width equals 80 minus 2L. Okay? And then what I can do is take my 80 minus 2L and substitute it into this equation for width, since they both equal width. Okay? And the reason I'm doing that is so that I just have one variable instead of two. Okay? Let's see, from here, let's just do a lot of simplifying. L times 80 is 80L. L times 2L is 2L squared. And we can rearrange it so that it's in standard form. I'll have the negative 2L squared first, and then the positive 80L second. In case you're curious, it's a plus 0, so that's a C value of 0. Okay? I can tell from here that I have a negative leading coefficient, which means if I were to graph this parabola, it would be a downward facing parabola. And that vertex point right here is where that maximum happens. Okay? So I'm going to look for the vertex to find the maximum. All right, so the vertex, let's see, the x value, but for us that'll be our L value of our vertex is going to be negative b over 2a to find it quickly. The opposite of b would be the opposite of 80, which is negative 80. 2a would be 2 times negative 2, which is negative 4. And negative 80 divided by negative 4 is positive 20. All right, so I've got 20 for my length. Let's see, it asks for the maximum area, doesn't it? So you have a couple options. One option is that we can substitute that 20 back into our area formula here and do negative 2 times L squared, that's 20 squared, plus 80 times L, which is 80 times 20. We can do it that way. 20 squared is 400. 400 times negative 2 is negative 800. Let's see, 80 times 2 is 1600. And negative 800 plus 1600 is positive 800. Whew, lots of math there, but we finally got it. Our maximum area is 800, and our units were in feet. So this will be square feet. There it is. Alrighty, and that's the y value of our vertex is 800. Okay. What are the dimensions of the rectangle? Well, we found length. We know the length is going to be 20 feet. Ta-da. And then we also need the other dimension, which would be width. And probably the easiest way to do that would just be to do width equals 80 minus 2L. So my width for that maximum area spot would be 80 minus 2 times my L value, which is 20. Okay, 2 times 20 is 40, and 80 minus 40 is 40. So now I have my width, which would be 40 feet. And there's my dimensions. Just in case you're curious, if you drew it this other way, where you have two widths and a length, you'll have these exactly flipped. You'll have a length of 40 and your width would be 20. So it's still a 20 by 40 rectangle. It would just be flipped if you drew your diagram differently than I drew mine.